13.2 is about angles in the unit circle. So we're getting into trig a little bit here and going on with these angles in the unit circle and how they're interrelated. So you look at this stuff here. Which of the following angles is not coterminal with any of the other three? So again, when you're dealing with a unit circle, you're dealing with an XY axis, and each one of the bars represent 90 degrees. So if you draw an angle, change colors. If you draw an angle here and here, that's 90 degrees. Then here, obviously 180, here's 270, and then all the way around is 360 degrees. So if we're looking at this here, let's look at one of these angles. Let's look at 60 degrees. It doesn't really matter how you draw it, but this right here is going to be 60 degrees. Okay, well, what's negative 60 degrees? Positive is going counterclockwise. Negative would be going clockwise. So negative 60 is going to be down here. So obviously those are not coterminal. The word coterminal means basically that they end at the same side. By definition, it says they have the same terminal side. That just means where they end. So if we're going to look at, let's look at 300 degrees. Okay, so let's start here. That's positive, so we want to go around the arc. Let's go, I don't know, green. 300, this is 90. There's 180. There's 270. Well, 60, that leaves 40 here, so that's going to be where 300 degrees is. Why? Because if this is 60, that means we're left with 30 here. I'm sorry, not 40. 30 degrees there. So 270 is here, and then 30 to here is 300. So those two would definitely be coterminally end at the same spot. Well, let's look at negative 420 degrees. Let's do purple for it. So again, you're starting here, you're going around. That's 90, that's 180, that's 270, there's 360. Well, what's another 60 degrees? Well, 360 plus 60 is 420. So this one, and this one are all coterminal. Your answer here is C. And here's your first picture of a unit circle, and what you'll notice is that it's the distances or the radius is always 1 on each axis. So if you look right, up, left, and down, it's all 1 or negative 1 depending on where it is. Suppose an angle in standard position has a measure theta. The cosine of theta is the x-coordinate of the point at which the terminal side of the angle intersects the unit circle. The sine of theta is the y-coordinate. So cosine theta is your x, sine theta is your y. And again, you'll see 30, that's why we kind of did the special right triangles yesterday. So if I'm looking at this, what's the cosine theta and sine theta for 90, 180, and 270? Well, if we're looking at this, 90 degrees, see how it's 0, 1, so the cosine of 90 is 0. The sine of 90 would then equal 1. Well, let's look at 180. Again, cosine of 180, what's the x-coordinate? It's negative 1. The sine of 180, what's the y-coordinate? 0. Now let's look at 270. The cosine of 270 on a unit circle is equal to 0. The sine of 270 is equal to negative 1. Now example 5 talks about what are the cosine and sine of the individual angles. So this one is theta of 60 degrees. So let's look at 60 degrees on the unit circle. Okay, so if we have this and we have a unit circle, I'm terrible at drawing circles. 60 degrees is going to be this angle right here. That's 60 degrees. Now if we look here, we can go ahead and create a right triangle by just dropping this straight down. That creates a right triangle with that angle being 60 degrees. Well, this right here, this part from the center to the circle is 1. It's a unit circle. It's always going to be 1. So then we set up our 30, 60, 90 degree triangle. S radical 3, 2S. Okay? Remember, we put the equal signs here if you want, but the 1 is opposite what? The 90 degree. So then what's S equal? Well, remember, to solve, divide by 2. So my S is going to be 1/2, and this is going to be radical 3 over 2, or 1/2 radical 3, which gives me radical 3 over 2. Okay? So we're looking at this point, we'll call it P, X, comma, Y. The cosine of 60 degrees, remember the x is the shorter side, so that's going to be 1/2. And the sine of 60 is going to be across from the longer side, which is radical 3/2. Okay, so I have a little bit better for drawing. B, you want to find theta of 225 degrees. So again, starting at this point right here, okay, go around. This is 90, then 180, then 225. Well, how far is it from 180 to 225? So let's take this down and drop a right angle here. So we have the right triangle. Well, how far is that from the 180 to 225? 225 minus 180, that's simply 45 degrees. So we have a 45 degree triangle. So again, we set up our box, 45, 45, 90. S radical 2. Again, the 1's across from there. So this, again, how do we solve? Well, divide by radical 2. You end up with s equaling 1 over radical 2, but we can't do that. Remember, we're going to multiply by radical 2 over radical 2 for simplest form. That gives me square root of 2 over 2. So my side length is radical 2 over 2, both sides. And you kind of hope that gives you 45, 45, 90, because then your cosine and your sine are going to match. Your cosine of 225 is going to equal radical 2 over 2, and your sine of 225 is going to equal radical 2 over 2 as well. And they're both negative because they're in the third quadrant.